Bismillahirrahmanirrahim. Assalamu alaikum students. Today I will cover some remaining topics of chapter 1. First topic is measures of historical rates of return. Under historical rates of return we will study holding period return, holding period yield, arithmetic mean and geometric mean. Secondly we will discuss arithmetic mean versus geometric mean. Third, portfolio of investment, and the last topic will be expected rate of return on portfolio. Measures of historical rates of return. First, we will discuss what is holding period return. The period during which you own an investment is called its holding period, and the return for that period is the holding period return. For example, if I'm holding the investment for 1 year, my holding period is 1 year, and the return I'm earning on that period is the holding period return. For example, if you commit $200 to investment at the beginning of the year, and you get back $220 at the end of the year, what is your return for the period? The formula for the holding period return is equals to ending value of investment divided by beginning value of investment. So our ending value is $220 and our beginning value is $200. So we divided $220 on $200 and we get 1.10, which is the index value. If the index if the index is greater than 1, it means the ending value of investment is greater than the beginning value of investment. Next, we determine the holding period yield. The holding period yield is determined in terms of percentage. The formula for the holding period yield is holding period yield equals to holding period return minus 1. In this case, our holding period return is 1.10. So we subtract 1 from the 1.10, we get 10% holding period yield. Now we determine the annual holding period return. The formula for the annual holding period return is holding period return power 1 by n, where n is the number of years investment is held. Annual holding period yield is equal to annual holding period return minus 1. Let's take an example to determine annual holding period return and annual holding period yield. For example, consider investment that costs $250 and is worth $350 after being held for 2 years. So determine holding period return is equal to ending value of investment divided by beginning value of investment. So in this case, the ending value of investment is $350 and the opening value or the beginning value of investment is $250. So we divided the 350 on 250 and we get 1.40. The formula for the annual holding period return is equal to 1.40 power 1 by n. And after putting the values, we get 1.1832. And holding period yield is equal to 1.1832 minus 1, and we get the 18.32% holding period yield. So it is very easy to determine the annual holding period return and annual holding period yield. Now we will discuss the two mean measures, arithmetic mean and the geometric mean, to determine the mean returns of a single investment or a portfolio of investment. First, we look at the arithmetic mean. The formula for the arithmetic mean is summation holding period yield divided by n. Summation holding period yield is equal to the sum of annual holding period yields. Geometric mean. The formula for the geometric mean is equal to pi HPR power 1 by n minus 1. Here pi is equal to the product of the annual holding period returns as follows. Holding period return 1 multiplied by holding period return 2 multiplied by 3 and multiplied by 4 and so on to n series. Let's take an example to determine the arithmetic mean and the geometric mean. In the first year, the beginning value of investment is $100 and the ending value of investment is $115. In the second year, the beginning value of investment is $115 and the ending value of investment is $138. In the third year, beginning value of investment is $138 and ending value of investment is $110.4. So in the first year, the holding period return is 1.15 and the holding period yield is 15%. In the second year, the holding period return is 1.20 and the holding period yield is 20%. And the third year, the holding period return is 0.80 and the holding period yield is negative 20%. It means that there is a loss in the value of the investment. So first we calculate the arithmetic mean. So what we do here, we just add all the holding period yields, 15% plus 20% plus my negative 20% and then divided total number of years. We get 5% arithmetic mean, which means that on average on this investment, we earn 5% return in 3 years. Now we calculate the geometric mean. We use the formula for the geometric mean. Here we multiply the holding period yield of first year with the holding period yield of second year and the holding period yield of third year. So it is the product of holding period yield first year, holding period yield second year, holding period yield third year, and we get 3.353%. So the geometric mean is less than the arithmetic mean. We use both the mean measures to determine the mean returns of this investment. But here we can see that the two mean methods are giving us different results. So what is the reason that geometric mean is less than the arithmetic mean? Arithmetic mean versus geometric mean. Now we will see that how geometric mean is a better measure than the arithmetic mean. Since investors are typically concerned with the long-term performance of the alternative investments, so GM is considered a superior measure of the long-term mean rate of return. Why it is considered as a superior measure? Because it indicates the compound annual rate of return based on the ending value of the investment versus its beginning value. If we take the prior example, if we compounded 3.353% for 3 years, we would get an ending wealth value of 1.104. So the beginning value of the investment was $100, and if you multiply 1.104 with $100, you will get the ending value, and that was 110.40. Now through example, we will see how geometric mean is superior than the arithmetic mean and how arithmetic mean sometimes misleads us. So in case of a volatile security, volatile means a risky security, arithmetic mean is biased upward if you are attempting to measure an asset's long-term performance. For example, a security that increases in price from $50 to $100 during a year 1 and drops back to $50 during year 2. The annual holding period yields would be: first year beginning value is 50, ending value is 100, and the holding period return is $2 and holding period yield is 1%. In the second year, the beginning value is 100 and the ending value is 50. So the holding period return is 0.50 and the holding period yield is negative 0.50. In this next slide, we will determine the arithmetic mean and the geometric mean. So we use the data in the previous slide and we have computed the arithmetic mean. The arithmetic mean of this security is 25%, whereas there is no change in the wealth and therefore there would be no return. Yet the AM rate of return is computed to be 25%. If you remember the last slide, the initial investment was $50 and at the end of the year 2, the value was again $50. So there is no change in the price of that security and there is no change in the wealth of the investor. So there must be a 0% return. But arithmetic means tells us that the investor has earned a 25% return average in 2 years. Next, we have computed the geometric mean of the same security. So we have computed the geometric mean, and the geometric mean is 0%. This answer of a 0% rate of return accurately measures the fact that there was no change in wealth from this investment over the 2 year period. So you can see here, you can compare the arithmetic mean with the geometric mean, and you can find that the arithmetic mean in this case is misleading, whereas the geometric mean is providing us the accurate result. So there is why that the geometric mean is superior than the arithmetic mean, particularly in the case when the securities are volatile. So after comparing the arithmetic mean with the geometric mean, we can draw some conclusions. So the first conclusion is, when rates of return are the same for all years, the geometric mean will be equal to the arithmetic mean. And if the rates of return vary over the years, the geometric mean will always be lower than the arithmetic mean. The difference between the two mean values will depend on the year-to-year changes in the rates of return. And the last is that larger annual changes in the rates of return, that is more volatile, will result in a greater difference between the alternative mean values. So now we will see how to determine the return on a portfolio of investment. As you know that the portfolio of investment means the collection of investments. So the mean historical rate of return for a portfolio of investments is measured as the weighted average of the holding period yields for the individual investments in the portfolio. So it is very easy to compute the holding period yield for a portfolio of investments. It is just taking the weighted average of the holding period yields for the individual investments. In the next slide, we will see how to compute the holding period yield for a portfolio of investments. Now I will show you how to compute the holding period yield for a portfolio. For example, if we have invested in three stocks, stock A, B, and C, and the ownership in stock A is 100,000 shares, and ownership in stock B is 200,000 shares, and ownership in stock C is 500,000 shares. The beginning price for stock A is $10 per share, and the beginning price for stock B is $20 per share, and the beginning price for stock C is $30 per share. The beginning market value of stock A is, we multiply the beginning price per share with the number of shares, and we get the beginning market value of stock A, and it is $10,000. Then we multiply beginning price of stock B, $20 per share, with the number of 200,000 shares, and the beginning market value of stock B is $400,000. Then we multiply $30 per share with the 500,000 shares, and we get the beginning market value of stock C, $150,000. After adding up all the beginning market values of stock A, B, and C, we get the total beginning market value of our portfolio. So it means we have invested $20 million in this portfolio. The ending price for stock A is $12 per share, and the ending price for stock B is $21 per share, and the ending price for stock C is $33 per share. So we have calculated the ending market value of stock A, B, and C in the same way we have calculated the beginning market value of stock A, B, and C. So we have multiplied $12 per share of stock A with the 100,000 shares. Then we multiply the $21 per share with the 200,000 shares. And then we multiply the $33 per share with the 500,000 shares of stock C. After then, we have added up all the ending market values of stock A, B, and C, and the total ending market value of this portfolio is $21.9 million. After that, we have calculated the holding period return for stock A, B, and C. The holding period return for stock A is 1.20, and the holding period return for stock B is 1.05, and the holding period return for stock C is 1.10. Then we calculated the holding period yield for stock A, B, and C, and the holding period yield for stock A is 20%, and the holding period yield for stock B is 5%, and the holding period yield for stock C is 10%. In the next step, we have calculated the market weights. So we have multiplied the beginning market value of stock A we have divided the beginning market value of stock A on the total beginning market value of stock A, B, and C. So we have divided the $100,000 on the $20 million and we get 5% weight for stock A. Similarly, we divided $40,000 on $20,000 and get the weight of stock B. And then we have divided the $150,000 on $200,000 and we get the market weight for stock C. After then we have multiplied the market weights with the holding period yield and we get the weighted holding period yield for stock A, B, and C. And for stock A it is 0.010 and for stock B it is 0.010 and for stock C it is 0.075. After then we have added up all the weighted holding period yields and we get the weighted holding period yield for a portfolio and it is 0.095, or in other words you can say that it is 9.5%. And another way to determine the holding period return is that we have divided the ending market value of a portfolio on the beginning market value of a portfolio. So here we have divided the ending market value of a portfolio on the beginning market value of a portfolio and we have determined the holding period return. It is equal to 1.095. And after then the holding period yield is equal to 1.095 minus 1 and the answer is 0.095 or 9.5%. So we get the same answers in both the cases. So in this way you can determine the holding period yield for a portfolio. Expected rates of return. The last topic of this lecture is how to determine the expected rates of return on an individual security. इससे पहले अभी तक जो आपने पढ़ा है उसमें हमने सिंगल रेट ऑफ रिटर्न जो था उसको डिटर्मिन किया और सिंगल रेट ऑफ रिटर्न को हम यूज कर रहे थे, लेकिन यहाँ पे एक्सपेक्टेड रेट्स ऑफ रिटर्न है यानी एक इन्वेस्टमेंट के ऊपर ये पॉसिबिलिटी है कि उससे हम डिफरेंट रिटर्न्स एक्सपेक्ट कर रहे हैं। यानी इसकी वजह ये है कि एक इन्वेस्टमेंट जो है वो रिस्की है और उसके ऊपर हमें सर्टेनिटी नहीं है, 100% श्योरिटी नहीं है कि हम एक्सपेक्टेड रेट ऑफ रिटर्न जो अर्न कर सकते हैं। अगर हम एक्सपेक्टेड रेट ऑफ रिटर्न अर्न नहीं कर सकते then there is a possibility that in different situations or different scenarios we can earn different returns. अगर इकोनॉमिक सिचुएशन फॉर एग्जांपल चेंज होती है तो हम जो है वो सेम रिटर्न अर्न नहीं कर सकते जो कि नॉर्मल कंडीशंस में हम रिटर्न अर्न कर सकते हैं। एक्सपेक्टेड रेट ऑफ रिटर्न जो होता है जो नॉर्मल कंडीशंस में होता है वो मोस्ट लाइकली रिटर्न होता है, लेकिन अगर मार्केट के अंदर रिसेशन होगा तो फिर हम वो रिटर्न अर्न नहीं कर सकेंगे जो कि नॉर्मल इकोनॉमिक कंडीशंस के अंदर हो सकता था। इसी तरह अगर इकोनॉमी के अंदर बूम आता है तो फिर आप वो रिटर्न अर्न नहीं करेंगे जो कि आप रिसेशन में या नॉर्मल कंडीशंस में आप करते हैं, तो आपका जो रेट जो पॉसिबल रिटर्न होगा वो डिफरेंट होगा। सो द क्वेश्चन इज व्हाट इज द प्रोबेबिलिटी दैट वी कैन रिसीव a certain rate of return under three scenarios. प्रोबेबिलिटी क्या होता है? बेसिकली प्रोबेबिलिटी जो है इट्स चांस ऑफ अकरेंस, कि किसी इवेंट के अकर होने का क्या चांस है, रिसेशन के अकर होने का क्या चांस है, नॉर्मल कंडीशन रहने का क्या चांस है। इसी तरीके से जो है वो बूम इकॉनमी के अंदर बूम होने का क्या चांस है। तो हम जो है वो प्रोबेबिलिटी को एसोसिएट करते हैं, ये एक सब्जेक्टिव चीज़ है, ये ऑब्जेक्टिव नहीं है, क्योंकि हम इसके अंदर हिस्टोरिकल रिटर्न्स को या हम फोरकास्ट कर रहे होते हैं फ्यूचर को कि फ्यूचर में क्या इकोनॉमिक कंडीशन हो सकती है, उसकी बेस के ऊपर फिर हम प्रोबेबिलिटी एसोसिएट करते हैं कि अगर ये सिचुएशन होगी तो फिर कितना रिटर्न हम अर्न कर सकते हैं। तो इसमें जो एक्सपेक्टेड रिटर्न ऑन इंडिविजुअल सिक्योरिटी है उसमें आप सिंपली प्रोबेबिलिटी जो है उसको मल्टीप्लाई कर देते हैं उसके एसोसिएटेड रिटर्न के साथ, और जो भी पॉसिबिलिटीज, जितनी भी पॉसिबिलिटीज होंगी उन सब की प्रोबेबिलिटीज को आप मल्टीप्लाई करेंगे उसके रिस्पेक्टिव रिटर्न से और ऐड कर देंगे, तो यू विल गेट द एक्सपेक्टेड रिटर्न ऑन द इंडिविजुअल सिक्योरिटी. So in this way we can determine the expected return on individual security. So I think it is enough for today. Inshallah we will discuss it further